how I started or how everything started when I decided to go a bit more focused on STEM.
Hello,
There.
distinguished teachers, facilitators of learning, custodians of our next generation of innovative thinkers, problem solvers, and creative thinkers. You are welcome to this session of the Space Science in Education Summit. I have here with me Alvaro. Alvaro, I am super excited to have joined us. Training really. It yourself with these mindsters.
First of all, I am going to have to answer that with them. I mean, because lecture with you, but I'm teacher, my name is teacher Alvaro. I'm an assistant teacher from Cali, Baja California. I'm located in Vallejo, California, and I'm a multitask teacher. And I had the great privilege to be part of this amazing group of teachers, and I was able to meet all along. And I'm really excited to be part of this workshop, and I hope my story or my lessons or things that I've been working throughout this years can help you guys to within your classrooms, and I'm super excited to be here.
Thank you. All right, so what do you have for us this day?
Okay, really quick, it's just how I started or how everything started when I decided to go a bit focus on still my for my talk goes. Got it. Which is into space. So in this particular case, I'm very interested in that I have worked with some of the people for NASA. I got a title in one. And I've been working with all these wonderful organizations such as Space Foundation, now with Limitless Space Institute, NASA, the International Space Station, and the logo that is located on the far right is that is a STEM channel that different teachers from my state, from Baja, we work with different topics and we create digital content for teachers and students regarding science, technology, and everything in between. And regarding my professional, I've been certified by Oxford, by Cambridge, by the University of California, the Berkeley chapter. I worked at the United Nations Summit where I was speaking there. beginner camp, which was the water lending practice. They took us on this little capsule that you see here, and we had different roles that we had to play, and they threw the capsule to the artificial lake, and you had to work with your team and check your card to see what role were you playing, and we would have to fill that role and save the crew. Then the moon landing practice, it was a simulator where you either did the moon landing or you were working with inside space vehicle in order to guide your team members to go through the spacewalk. And then the last one was the Capcom practice. In this case, the Capcom practice was you get selected and you can kind of go into a room and it's sealed for like 2 hours, and you work with the crew that is located in space and the crew that's located here on a space station, and you have to work and communicate with different teams. That's why there's a line of people where each and every one of us has a specific task to work on, and it was a really amazing experience because I never had an idea of how everything worked. So Space Camp in 2018 gave me like a very good perception of how, in general terms, astronauts were trained, and also everything that happens like behind the scenes. Also, and during that time, I was able to meet other teachers from my.
Okay, welcome, Casey.
Hello. Sorry, my apologies.
Yeah, welcome. Okay. How do you do today? Trust you're good?
I am good. I'm excited. Lots of people.
So glad you have you join us today. How is it going?
Things
You're
are going
welcome.
really. Yes.
Been a roller coaster of activities, meetings, deadlines, and all.
Yes,
Thank you.
lots going on. Lots and lots going on. So, but excited to be here and share a few things with teachers.
So, distinguished noble colleagues and teachers, educators of the Federal Republic of Nigeria, it is my distinct honor to welcome Casey Hines, the Executive Director of the Limitless Space Institute. You already know I shared our profile with you on a video earlier on. So she's here to share with us on this Space Science in Education Summit 2.0. Make welcome in the chat. Can you welcome Mrs. Casey Hines? You have the floor. Welcome, Mrs. Casey.
Thank you. Thank you for that introduction, Olubanke. It's so awesome that you're putting on these events virtually to share all the amazing information that you've learned in this program and that others have been supporting as well, and to be able to continue to share this across Nigeria. So it's an honor to be here today. And what I'm going to share is, let me find the right slide, is we're going to focus on STEM careers. So we're going to focus on women in STEM, pioneers of space. I think it's really important that teachers take back to their classrooms all the different opportunities. This can be for boys and for girls, but we really want to empower women, young ladies in our classrooms, that they can be a part of the mission. And so I'm going to go through some of these different jobs that maybe people don't always know about. And that's something you can take back to your students to be able to share with them. And a lot of times people don't know what they don't know. So being able to share this helps them see a possible pathway for the future. So this is a field, aerospace and STEM, science, technology, engineering, and math is not always, I think, fully represented. We know it's a male-dominated area, and that's where, again, we know the need, we see the need for women in STEM, And so it's really important that we encourage that for our students, especially girls in the classroom. And so one of those jobs is engineering. So if your students like to tinker, to take things apart, put them back together again, this is where we have to encourage that creativity and innovation. And with this type of job, this is where, you know, as we're exploring space, there's a lot of things we've never done before. So thinking outside the box, being creative, thinking of different solutions, working with a team is mission critical. So making a space station or a habitat on another planet that has a different gravity field, there might be less gravity, little to no atmosphere, different types of regolith or soil, just all these different variables that we don't experience on Earth, being able to problem solve and design solutions to these different celestial bodies, so to speak. It's really challenging. It's really hard, but it's something that humans just seem to want to overcome. We want to solve this problem. We want to get out there and explore. So being an engineer, whether it's you're building a habitat, you're building a spacecraft, you're building a rocket, we need people to be able to solve these problems and solve these challenges. So that's where you have different types. You have aerospace engineering, mechanical engineering, electrical engineering, civil engineering. There's all sorts of different types of engineering to help narrow down that focus on what they're working on. Maybe they're working on how does a toilet flush on another planet, on the moon or on Mars. You have different gravity fields. Being able to think about those simple things that we take for granted every day and we don't even really think about, but how would we solve that problem with different variables on a different spacecraft or a different planet or a different moon? So that's where engineering becomes a super incredibly important aspect. Another is agriculture. So being able to grow things in space is also mission critical. It's not something we always think about, but a lot of benefits to learn how to grow plants in a unique environment such as space where there's no gravity can actually help different types of farming systems, maybe even better farming systems here on Earth. I know hydroponics is becoming more popular with using just water instead of actually a regolith. Because in space too, they don't want to take up just regular soil because it floats around. So you have to be able to contain the soil so it doesn't float away. Then how do you add water to it? Because again, you don't want the water to float away. You have to be able to figure out a new system. You have to engineer a new system to be able to ensure that the plants have a system to where their roots can grow and expand and get their nutrients, but also get water. And how can we have plants that produce fruit or vegetables possibly in a shorter amount of time? If we're on a long duration mission to Mars that takes 2 years, how are we going to get crops to be able to produce food for humans to eat? Because while ideally, we'd want to be able to pack all that, but I don't think it's really a reality. We have to be able to, that's going to take up a lot of space and a lot of mass. So that means you're going to need a lot of rocket fuel or multiple rockets. So you have to, and then it gets very, very expensive. So how can we look at the financial piece? How can we look at the benefit to those in space, but also how can we spin off and have a benefit for all of humanity? So being able to have astrobotanists, agriculture engineers, soil scientists, these are all careers here on Earth, but what if we apply them to space? There are lots of jobs in those areas because these are problems that people are trying to solve. Another one, fabrics. A lot of times we don't think about our clothes or what we're wearing in the sense of, well, how would this work in space, in microgravity? But it's very important. Material science in general, even outside of fabrics, just working with different materials in general is super important. space is really, really, really challenging environment where you have increased radiation, you have an extreme fluctuation of temperatures, you have, there's no air, there's no pressure. So it's the harshest environment known to humans. So how do you develop materials that can withstand that environment? And a lot of times, again, you get a spin-off that helps humans, everybody back on Earth. So, but maybe you have a young lady that's really interested in fashion. There's a place for that young student in space, because the spacesuits are made of many, many different layers to help protect the astronaut, because it's like a very small spacecraft. It has everything the astronaut needs to survive: water, air, carbon dioxide scrubber. The only thing they don't have is food, because you've got that faceplate in front of you, so you can't always you can't at all get yourself a snack. But it's really important because there's micrometeoroids. You have, again, the extreme change in temperature, you have radiation. So all those multiple layers have to not only protect the astronaut, but they have to allow them to be mobile. So you have to be able to move around and be able to do your job. So that's usually when they're doing a spacewalk. Usually they're adding something to the space station or fixing something on the space station. And it's really challenging. It takes about 2 to 3 hours, I believe, to get into the spacesuit and make sure everything is safe. But then you're going to stay in there for a while. So you have to be able to maneuver and do your job and do it really well. And it's not always easy in a pressurized spacecraft, so to speak. So looking at different materials to make it easier on astronauts, to make them lighter, all of that is really important as they design new spacesuits for different planets. Or if we're going back to the moon, I know they're designing a new spacesuit. Axiom Space has partnered with Prada, if you've heard of that company before. But even going to Mars will probably need a different suit as well. So those are different jobs in the material science realm. As you can see there, material engineer, textile engineer, composite materials scientist. So all sorts of different opportunities if there are students that just like to work with different types of either fabrics or materials, and see how they can bring them together to find solutions to problems. Human physiology is really, really important because of the different gravity fields. On the International Space Station, as you see astronaut Sunny Williams here, there's no gravity. So human muscles and bones start to deteriorate very, very quickly. And that's where we can't have that, because we need astronauts to be strong when they come back home. If they're going to Moon, Mars, and beyond, they have to be able to maintain their strength so that when they get to where they're going and have to complete a mission, they have the strength to do that. So even dietitians are very, very important. Food scientists to be able to put together the menus and the different types of food, and to ensure they're going to get enough calories, because every single minute of every single day is scheduled for the astronaut. And so ensuring that not only do they get adequate rest, that's mission critical, they have to have rest, but since they're so busy, they're burning a lot of calories. So they must have the right amount of food, and it has to taste good. That's a psychological effect where humans love to get together and eat. We love nice types of food. And so making sure that the astronauts enjoy their food while they're in space is really, really important. And they have a bunch of food testers here on Earth, human test subjects that try these different foods. I was actually able to do that when I was in Houston, and it's pretty cool. You get to just try these different foods and rate it, and you're trying to help the astronauts in picking things that they would probably like. Ultimately, they have the final voice and opinion on that. But those are just jobs that most people don't think about, like a chef, like being able to put together a menu and different diet needs, requirements that the astronauts need in space. So along with sleep and food and calories, you also have to make sure they're exercising. So biomedical engineer, occupational health specialist, space medicine. I mean, they need astronaut doctors and nurses. That's what it boils down to. And so the astronauts in training must train for sometimes years in advance. If they're with NASA and going up for a 6-month mission, everything is regulated here on Earth. Make sure they are fit and in shape and healthy. And also when they get up there, this is a treadmill. So it's very small, but you can see that there's a bungee cord there because we know with no gravity, every action has the equal opposite reaction. So when Sunny pushes off the treadmill, she's going to go up and she'll just keep going. But thanks to these special harnesses and these bungee cords, they pull her back down so she can continue running on the treadmill. And I believe this may be a photo from when she did the Boston Marathon from space. So she ran 26.2 miles on this itty bitty little treadmill at the same time they were running the marathon back on Earth. So that's impressive. They also have a weightlifting machine. And they also have a little small bicycle, resistance bands. Usually resistance bands are what work pretty well in space. Astronomy and space observation is important as well, using the night sky to determine where you're at and being able to make observations from Earth for different missions, to be able to observe the moon, to be able to observe Mars. This is really, I think, a beautiful part of the mission because there's just so many amazing things to see. And planetary scientists, you have planetary geologists, you have so many different jobs related to doing research on other celestial bodies, other planets, other moons. And there's a very exciting mission called Europa Clipper right now that's going to a moon of Jupiter. So they think, well, it's covered in ice, so they're just very curious to see what this moon looks like up close and be able to see maybe there's possible microorganisms or things living underneath the ice in the actual fluid water. So very exciting mission that you can follow online. So being able to observe the night sky and the other objects in our solar system and our galaxy and beyond is absolutely beautiful and also a very important part of the mission. Computer science, this is really big. I think kids these days just love anything technology, get their hands on technology. So computer science is a very rapidly growing field. So if students can code, there's probably some sort of job for them somewhere, whether it's designing software, analyzing data, analyzing systems. And that's really what going to space is all about. You're going to have computers. You're going to have people that can code and debug and find solutions to problems. And as we're planning for these different missions, they're going to need different softwares. It's a whole new area of being able to, okay, we need a system for this. We need the system for the water or the carbon dioxide or the oxygen or all these different systems to make sure the humans stay alive, to make sure your propulsion systems can get you where you need to go. So all of these different systems have to have the computer software behind it to help them manage. And not only manage while they're in space, but as you can see, this is mission control here in Houston. So this is a lovely flight director. You can see she's got, I think, 3 or 4, maybe more screens there at her desk. And that's what they all do. They all at Mission Control have a lot of screens because they're monitoring a lot of systems all at once. This actually might be an astronaut schedule, all the different astronauts and their schedules there and what they're doing throughout the day. So, having people that know how these systems work, they design them, they code them, or they use them is all an incredible part of the mission. So now we get into more of the art part, graphic design and visualization. So maybe you have students that are not super into the tinkering piece. Maybe they have the more artistic side of things and can see things from a different perspective or through a different lens. And that's where you need your graphic designers, because a really important piece of the space mission is telling the story. And that is what Olubanke is doing, and other teachers in the Limitless Space Institute cohort. They are sharing the mission. And so they had to use a little bit of graphic designer in them to create their flyers for this, to get you enticed to come and sign up or watch live. So being able to take the story and be able to share that with others is a really important piece that most people don't always think about. User experience. So that probably would be web design or software, being able to go to a website and being able to click through and learn information about a specific mission or about a specific astronaut or about a different spacecraft and what its mission is. So being able to take that information and storytell is really, really important. And now with technology too, we can make these really beautiful and visual and exciting websites and flyers and social media. All of that brought together makes for a great story where it brings people in to want to be a part of the mission. And so that ties in with the communication piece. So you have the art piece, but then you also have being able to tell that story. So if students are into podcasts, or if they love to write, being able to write up those stories, write up the blogs, or if they are into the video piece, the vlogs, being able to report on things through using video. All sorts of multimedia is out there, and it always seems to be changing. I can't keep up with all the TikToks and Snapchats and all the other things, but that's a really important piece that maybe because I'm older, I'm not as savvy with. But this up and coming generation, they seem to be really into it, as my 16-year-old son seems to be and knows how to do all the things. But that's an important piece, is being able to identify students, up and coming students or graduates that have those skill sets that definitely I don't have, to be able to share the story. So that's where you have your public relations specialists, your science communicators is really important, and social media, because we know the kids are really into social media right now. And this here is a picture of actually using radio. So not always as common, but this is where the astronauts can get on the radio and use radio waves to talk with different schools and students and people in general. If you have your license, you can actually try to talk to an astronaut as they're passing overhead during the day or at night. So pretty cool. And then the last one I'm going to touch on is space law and ethics. And again, something people do not always think about, like a space lawyer, or why do we have space law? Well, this is, new territory for humans. On Earth, we have our maps and we like to have our boundaries. But from space, there are no boundaries. There are no separation of states or countries at times, but that's when we go out to space, that's really, we have to be able to work together. We have to be able to come together for the mission. So being able to have rules and guidelines for people to follow when they're in low Earth orbit, as astronauts currently are right now. Going back to the moon is going to be mission critical, because there are going to be multiple countries going. Even China wants to go to the moon. I think their target is 2030. So being able to have humans where we have different countries back on Earth to say, okay, we're going to this place that is not owned by anyone, and it's supposed to be coming together for science and research and being able to, again, help benefit everybody back on Earth. How do we set forth guidelines to where everyone can get along, can meet those needs, and be able to be safe? So currently, with going back to the moon, there's a document called the Artemis Accords, which many, many different countries from all over the world, including Nigeria, have signed, showing that they're coming together in the essence of being able to work together in space and for scientific research on the moon. So, but then you have to think about Mars. Mars is definitely a destination we want to go to, and then other places down the road with hopes with that. Having people in place to be able to draft up those documents, to be able to work with other companies or countries is really, really important. And again, it's not something we always think about, but maybe you have a student that likes to do that kind of research or is really good at formal debates. This might be something right up their alley. But it's really an important piece to show that as we continue to explore, that humanity is coming together for a common goal, and we are in this together, and it should be all done in peace, again, for benefit of everyone back on Earth. So excited to see where that goes in the future. So that pretty much concludes my presentation. So those are just a handful of different careers. There are hundreds more careers. If there's a job you can think of on Earth, they are going to need it in the space industry. They're going to need it when we go back to the moon, Mars, and beyond. There is a place for everybody in space, and everyone is truly limitless. And so Olubanke, thank you so much for having me. Looks like I have a couple minutes, but is there anything else you need from me? Because this was a lot of fun.
Okay, thank you so much for this presentation. It is mind-blowing, and I know my distinguished noble colleagues, they have gotten a lot of ideas and work with in their various classrooms. I'm checking the chat to see if anyone has questions. We will have a minute or two to take questions. Let me check the chat. Thank you so much for the fantastic presentation.
Thank you. Thank you for having me.
So I'm checking the chat. Well, if anyone has questions, we can compile the questions and have them sent to you. They are all saying thank you. Thank you, thank you, thank you. They're saying thank you in the chats. We thank you. Up next, we have Logan in the building. Mr. Logan Jaren. We are so pleased and honored to have you join us this afternoon. Mr. Logan, he designed vision patches for us, and it was quite beautiful, showcasing our culture and all. I will still post a video to tell you more about Mr. Jaren. But in the meantime, can we all make welcome Mr. Logan Jaren in the chat? Give him a warm welcome. You're welcome, sir.
Yeah, thank you.
The teachers are on YouTube live stream now, and they can see you. They are welcoming you in the chat. Thank you for coming.
You are very welcome. I'm very honored and humbled to be invited to address you and your delegation of educators in Nigeria. It's quite an honor. So thank you. I will let me share my screen. There we go. So today I'm going to talk about emblems, actually patches, and to help you, inspire you to use emblems as a way of sparking curiosity about space. And these emblems can actually lead to research and interest in STEM as well as STEAM, the arts. So my name is Logan Yerin. I live near Seattle, Washington, on the west coast of the United States. I'm the founder of STEAM for Space, which is just a personal passion project to assist you with creating unforgettable learning experiences. And so I was happy to see Casey. So she has helped me by inviting me to some of her events. And as such, I'm what I consider an informal STEAM educator. So focusing on the science, technology, engineering, arts, and mathematics. My background is as a patch collector and a curator of patches. I'm also a storyteller, so I collect stories told by astronauts and space artists about the emblems that they have used and designed. I consider myself a space a space historian and a space hipster. I'm wearing my graphic tee with all my emblems here to inspire you for the next thing. So let's talk about emblems. So I connect students to STEAM using real mission patches and storytelling. So I'm going to give you some resources and and inspire you on some activities that you can do in the classroom with your students. So let's start off with some words. So there's a lot of words that describe, graphics. So insignias is a word that describes usually a graphic that represents an organization or an agency. So here's a familiar one for NASA, but you also have your own for the National Space Research and Development Agency. So these are what are considered to be insignias that represent an organization. We have the term emblems. So emblems is usually a graphic of a mission or a project or a team. So this is an example of one of the missions, the early shuttle missions by Challenger. And we'll come back to that one. Now we come up with the words of badges and patches. So these actually mean the same thing, but depending on where you live on the planet, you might use badges versus patches. In the United States, patches is a word that describes an embroidered emblem, such as this NASA emblem here. Badges might be the term that you use in Nigeria. It's also a very popular word for patches in Europe. Okay, so we're gonna start off with just looking at one of the more familiar emblems that we have, or the insignia for NASA. So of course we got NASA, we got the name, we got the acronym, the National Aeronautics Space Association. But the design of this is very intentional. So the circular shape represents planets, not necessarily the Earth, but it can represent any planet. So that's the circular shape. And you see the stars in the background, and that indicates space. And then we have an orbiting object that encircles NASA, and that represents space travel. And then we have this red element that is in the NASA insignia. And this actually represents aeronautics. And I will show you that the inspiration for that shape actually came from a real thing. This is a photograph of the shape. It was a real wing that was in a wind tunnel that was being tested, and somebody saw this and they were inspired by what they saw, and so this is represented as the red wing, or for aeronautics, within the NASA insignia. NASA also has another type of insignia. It's called the worm, and so these two insignias together represent NASA and different views of NASA in time. This is not something that you see very often. This is the actual seal of NASA. So it has a similarity to the insignia to the organization, but there is an official seal for NASA itself, and that's what that looks like. Okay, sparking some interest in STEM. I'm going to start off by telling you a story about one of the most iconic patches that has ever been made, Apollo 11. It represents the very first landing of people on the moon. And so this emblem is probably one of the most recognized emblems of all of the what they call human spaceflight missions. But I'm going to tell you something that not a lot of people know, not even people within the space program. There is an error. There is an error. I want you to pay attention to the shadow in the craters and the shadow on the Earth. And it turns out it's wrong. It actually is wrong. So Michael Collins, who is the command module pilot for Apollo 11, was the person who was invested in creating the design for Apollo 11. And he got a lot of input and a lot of influence from lots of different people because this was important. It was important to represent this mission in a way that would be forever, that would be essentially be a forever representation for this mission. But there is an error. And so it's the shadow. And I tell you this story because this is a photograph that was taken during Apollo 8 by Bill Anders. But this is where the shadow should be on the Earth. It's not on the left side. It's actually along the bottom. And so I tell you this story because this is even though there's an error in the actual emblem, because Michael Collins was an engineer, he wasn't an artist, and he wasn't a scientist. So it was something. There actually is quite a few errors in a lot of the emblems. This is an error that I love because it is an opportunity for you to have a conversation with your students about where would the sun have to be in relationship to the moon and the Earth in order for this shadow to be cast correctly. And there's actually something called, there's a program that is called Stellarium. And I'll spell out the name in just a moment. So Stellarium is actually a free software for Mac and Windows. It also has a web version and also a mobile version. And it's free to use. And it is awesome because it allows you to actually place yourself on, not just looking at the sky from Earth, but it also allows you to place yourself on different planets or different planetary bodies. So here's an actual view within the application from standing on the moon, where the Apollo 11 crew landed on the moon, looking back at Earth. And Earth is high up on the horizon, off of the horizon. And I'll zoom in just a If we were to zoom in, you can kind of see that the shadow is along the bottom. This is actually using real application, real science. And Stellarium actually allows you to have a conversation with your students about where is the sun? Where does the sun have to be in order to cast this shadow, the moon shadow onto the Earth? Where would that be? And so this is stellarium.org. You can download and use the Mac or Windows or even the web version through your web browser to allow you to experience the night sky and also to have different views. You can actually place yourself on Mars and actually look around Mars at the night sky for Mars. So it's a wonderful application. Okay, we're going to do a quick design analysis, and this is part of my STEAM for Space program. I love the Space Shuttle program because the Space Shuttle program, there was 135 missions, and every mission had its own mission patch, and every mission patch tells a story. So I'm going to help you understand some very common elements that are very common in different emblems. One of those, out of these 12 mission patches, take a moment to kind of look at what is common amongst these 12, and just take a quick moment and scan each one. Okay, and these are actual the actual designs of 12 of the Space Shuttle missions. So some of the most common elements, one of the most common elements in mission patch designs is the astronaut pin. And the astronaut pin is actually awarded, this is a gold, and there's actually two. There's a silver and a gold. The gold one is actually awarded to men and women who flew in space. They were trained NASA astronauts, and once they fly into space, once they fly into space, they are given a gold astronaut pin to acknowledge their flight in space. So the astronaut pin shows up, and even though it does, you'll find some examples of where that astronaut pin, like down here in this one, what's called Astro 2, there are kind of a graphic abstract representations of the astronaut pin. But indeed, the astronaut pin is actually in every one of these 12 patches. Another one is the spacecraft. In this case, it's the Space Shuttle Orbiter that shows up very common. Of course, these are space shuttle missions, so that stands to reason. The other one is the Earth. So the Earth actually is represented in every single one of these patches, but sometimes they're
Hello,
not very.
Logan.
Yeah?
Mr. Logan.
Yes?
I can't see your screen.
You cannot see my screen. Oh. Let me see.
Okay.
I will reshare. We'll see if that works.
Okay. Yes.
Can you see my screen now?
Yes, I can see your screen now.
Okay.
I can see your screen now.
All right.
The network is fluctuating, so it bounces out sometimes.
Okay.
You can continue now.
Thank you. So one of the more common elements in mission patches is the use of stars. So stars often represent the crew. So oftentimes when you count the number of stars on a mission patch, oftentimes each one of those stars that are shown represents a member of the crew, but not always. In some cases, it can represent the mission designation. So it can represent like the number 76, where you can have a group of 7 stars in one place and 6 stars in another. Stars is very often used to help to honor, to commemorate family members, friends, children of the crew, and also crew that have been lost in accidents, like for the Challenger accident and the Columbia accident. Stars could represent them. Okay. But the things that are not common in mission patches is actually the things that the details that we should pay attention to, because it's the things that are not common, such as those elements I just showed you, that actually lead you to STEM, leads you to the science, technology, engineering, and mathematics. Here's an example of a mission patch, excuse me, of a mission patch that the patch itself actually has elements of the helmet of a spacesuit worn by, as an example, Anna Fisher is the one wearing the spacesuit. If we take a close look into this patch, you see the Space Shuttle Orbiter, you see a robotic arm, it's holding out some kind of device. It's deploying a device into space. There's an image of an astronaut that is repairing a satellite. And then we see the sun reflecting off the visor of the spacesuit, all contained within this design. It is those details, it is those unique elements that actually direct you to the STEM that's related to the mission. So the space shuttle is literally a large bus that contains STEM. Here's an example of the Space Shuttle Orbiter Endeavour with its payload doors open. And what we can see is the robotic arm that is used to help to deploy and to capture probes and satellites. We see also that inside the payload is the payloads themselves. Here's an example of STS-118. And if you look at, on the left-hand side is an image of the payload for that orbiter. And it is just chock full of of STEM. It's got a microgravity space lab. It's got some equipment to attach to the to the International Space Station, which is the S5 truss. So a lot of the shuttle missions were used to help to assemble the International Space Station. So with every flight, it would carry materials, it would carry equipment, and carry things that it would actually use to help to assemble the International Space Station. And there's other things like the control moment gyroscope. This is actually a large gyroscope that is used to help to control the orientation of the International Space Station. And this is carried up on a space shuttle mission. So inside that payload, there's so much science and technology and engineering and mathematics. And the people and the people and the teams who were responsible for creating this technology and performing the engineering to create all of these things, they themselves had their own patches. So organizations and teams and projects like Canadarm, which is the group of Canadian engineers who created the robotic arm on the space shuttle, they had their own patch. Now, there's a lot of focus on the actual mission. So on the left-hand side is the mission patch for STS-31. This mission, this flight was the flight that deployed the Hubble Space Telescope. Well, the team of people who created the Hubble Space Telescope had their own patch, and it's on the right-hand side. STS-86. So one of the things that was done was that was performed, an experiment that was performed in microgravity, was space tomatoes. They actually took seeds to perform experiments in microgravity to see if the tomatoes would actually germinate once they were brought back to Earth. So that team that performed that experiment, that team had its own patch. There were student experiments. So there's experiments that were performed on space shuttle missions that were designed by students, college students, high school students, and even middle school students. And so these are examples of two of those. On the left-hand side, the experiment was about how spiders could make webs in space. And on the right-hand side was whether ants, a colony of ants, would actually do the things they normally would do on Earth. There are other mission patches like going to Mars. So each one of these missions to Mars had its own patch. We have OSIRIS-REx, which was a mission to an asteroid to bring back a sample. And then the Parker Solar Probe is a spacecraft, excuse me, is a spacecraft to study the sun. And it's currently the fastest spacecraft in space today. Back on Earth, there's analog missions. So there's actually several places on Earth that actually represent conditions that you would find on the moon and Mars. And each one of those missions had its own patch. And then there's fantasy. There's just the creative imagination of designers to create mission patches. All right, so we're going to do a hands-on activity.
Would you need a drink of water?
I got one. Thank you.
All right.
Yep. So we're going to do a hands-on activity, and this is something I'm just going to walk you through the activity itself. So at steamforspace.org is my website, and here you will find a lesson plan related to mission patches. Here's the mission patches, and you can click on the lesson plan. And the lesson plan is actually quite, it gives you a list of materials that you can prepare for this lesson. It gives you all of the resources and links to all of the resources. There are different types of curriculum or programs, but here we're going to focus on the lesson instruction. And so we actually did, there we go. We actually did the student, the design analysis. So I stepped you through that. So that's one of the first things to do with your students is that design analysis. And then the lesson plan assumes that students could actually be holding on to real patches. And if that's not your situation, you can still use this lesson plan But when you get to step 7, it provides you a link to missionpatch.info. So STEAM for Space is actually your site. It's an educator site. So don't share that with your students. But missionpatch.info is a dedicated site to help facilitate activities with your students. And so when you follow this lesson plan, it will give you a link to missionpatch.info. And here on this site that I've created, it gives you a photograph of a patch. And this is a souvenir patch, so it's smaller than the official size. This is what the official patch looks like when you examine it. And this is actually the graphic art. So this is the emblem design itself. And I provide a picture of both the smaller souvenir, the official patch size, and also the graphic art so that students can actually examine the details, which is important. In your particular case, what you can do is direct your students to this website and ask them to look at the patches that are on the page and find a patch that actually resonates with them, a patch that they actually, for whatever reason, is something that they actually like. There's something that they like about it. And so I'm going to pick on this patch, which is STS7. And so STS7, so if you look at the patch design, the actual mission designation is not indicated in the design, but so STS7, and so we're gonna look at that more closely. You're gonna look at the story, have your students actually follow the lesson plan and actually read the story about the design itself. In this case, STS7 was the first U.S. crewed mission for which the first American astronaut, a female astronaut, Sally Ride, flew on this mission. And so the description is really something that I've crafted using various sources to be able to tell the student what are they looking at. And then part of the lesson plan is going through and answering the essential questions. And there's downloadable resources. You can download the worksheets and have your students go through answer these essential questions. Answering the essential questions in this activity will actually lead you to, will lead the student to not just understand what the design of it, but also to understand, but the essential questions can lead to research, to deepen the research on the actual emblem itself. And so one of the things I'll point out to you is that the mission designation STS7, the number 7, actually shows up in the design. It actually is the robotic arm actually forms the number 7. There's also 7 stars, and it turns out the 7 stars is also representative of the mission itself. And there's the further details. There's currently 79 patches on the site, so there's quite a few patches for the students to kind of go and look at and find one that actually appeals to them, and then work through the worksheet. This activity seems rather simple, but the idea is it's like a really good children's book where you've got the illustration is the patch itself, the design, the story about the patch design is the story, and it sparks curiosity. This connection between the actual design, the story, actually builds bridges towards STEM. And that's really a focus of mine is to inspire students' interest and curiosity about the design and use that as a way to build a bridge and a connection to the actual science, technology, engineering, mathematics related to it. The arts part of STEAM is actually the emblem itself. Okay, there's a crew patch design activity that I've included. This the designs of things doesn't start with the artist. In fact, Joe Engel, who was the commander for STS-2, he actually has designed a number of the mission patches related to the missions that he flew. And this is an actual drawing that Joe created that started him thinking about what the design of his patch should be. Now, it evolved over time, and he collaborated with an artist to kind of come up with the final design. But it doesn't start off with a pretty picture. And in fact, so that's one of the reasons why I created this worksheet. It's on my website. It's called the Student Crew Patch Design Activity, And I created this because it was inspired by an activity that I had, that I was inspired by a similar activity. And so I adapted their worksheet to create a mission patch. And what this does is it helps, it's a small group activity comprised of 3 to 6 students. And you bring 3 to 6 students together and you have this sheet and you use a die. So it's a roll of the die that actually determines the design criteria for their mission patch, and it actually then assigns the crew patch, assigns the crew to different roles. It could be any student could be a mission specialist or payload specialist, a commander, or pilot. And so what this does is this helps take some of the initial decisions as chance by rolling a die. And it helps them focus. There's an entire worksheet that for which this group is challenged to collaborate, to come up with their mission, to tell the story of their mission, to decide what elements they want in their own mission patch. And so together at the end, they actually have not just a design of their own mission patch, but they now have a story that they get to share with other students within their class. Depending on the criteria. And it's worked really successfully. It's one of the things that you see on the left-hand side is actually one of the students in the group is designated as the artist. So they take all of the input and suggestions from the rest of the students to come up with a design. Some students actually, some classes and schools, they actually take the artwork that the students create and actually commission to have actual embroidered patches made from them. So these are options and opportunities to explore. Some of the origins, this started off with some of the origin stories that I collected from the crew members and also from just from historical record. So Apollo 13 is well known for the fact that it has horses in the design. Apollo 13 had the misfortune of having, there was an accident. And so instead of landing on the moon, it was a mission to actually to rescue and to rescue the crew. And as it turns out, no other crew patch since Apollo 13 has had horses on it. The actual design was inspired by a painting, a mural. This is a picture of James Lovell. He's the commander of Apollo 13. And he was inspired by this painting for the design of the mission patch. This mission patch is one of my favorite stories because the crew adopted a penguin as a mascot for their mission, inspired by a research ship. And so they were challenged to create, they actually put a penguin in the design of their patch, but it was rejected by NASA. NASA gets the final say as to what the mission patch, whether they're going to accept the crew's design for their mission. And so the idea of having a penguin in their mission patch was rejected, but they were very clever. They challenged the artist to include a penguin in their design. As it turns out, they used stars. So stars like a constellation, they actually came up with the idea of using stars to create a constellation that they made up called Penguinus, and in order to include a penguin in their design. So this is an emperor penguin that they were inspired by. So it was a very clever way of kind of getting what they wanted without being that obvious. Anna Fisher was the first mother to fly into space. As it turns out, if you count the stars, there's 5 stars for the 5 crew, but there's this one star off on the side, and that star represents her daughter because Anna Fisher was the first mother to fly into space. STS-133 was originally supposed to be the last shuttle mission, but then President Obama actually added 2 more missions to the shuttle program. But the artists who created this patch, who finalized the artwork of this patch, they did something really interesting. There were 2 men, Tim Gagnon and Jorge Cartes, who lives in Madrid, Spain. They actually included their initials. They have embroidered their initials into the design. At the top is actually the star that represents the artist who created this, the original design. And there's a couple of stars here that also represents the artist itself. very quickly, there's some personal patches. So Canadian Space Agency astronauts are very have a tradition of creating a patch that's very personal to them. So this is Robert Thirst's patch that he designed and wore on his mission on STS-78. This is the actual mission patch itself, and this is the graphic art. And it was inspired by Native American, essentially First Nations people, Indigenous people of Canada. Here's another Canadian Space Agency astronaut, and he was inspired by the Indigenous people's symbols that incorporated. So infusing culture is really kind of an important thing. Alyssa Carson is a 23-year-old aspiring astronaut. She has, since the age of 5, she proclaimed that her mission in life was to be one of the first people to walk on Mars, and she is pursuing that. I think it was mentioned earlier, I was part of the Limitless Space Institute's Global Educator Program that presented to educators to a team of educators in Nigeria. And I was so inspired by the stories that I was following on Facebook that I created an emblem that was inspired by colors and patterns. And I just want to say, space offers limitless possibilities for your students. And with that, I want to say thank you. Don't know if there's time for questions, but I'm certainly willing to take questions if that is possible.
Thank you so much, Mr. Logan, for your presentation. In the chat now, thank you so much for taking time off your busy schedule to do this. I am so inspired by the fact that every mission patch has a story behind it. Every mission patch has an inspiration behind it. And that's a very creative way to get our students to think critically and innovatively, regardless of the subject they do. And that's why in this gathering of over 861 teachers, the Teacher General Permanent Secretary of the Education District 4 in Lagos State. Lagos State has 6 education districts.
Wow.
The Teacher General, Mr. Olusegun Shinaike, he started this training with us. He delivered the keynote speech, and he's still right here with us because he's so committed to the fact that every Nigerian child should have access to quality education. So
yeah,
the mindset is changing. It doesn't have to be about skill alone. Even non-skill, they can fuse these principles for non-skill subject teachers. So I am really, really grateful for this. I am checking the chats to see if there are questions. Yeah, question. So I have a question here, and the question is for the mission patches, each mission patch, must it always have a story behind it? What is the aim of creating a mission patch?
The aim of creating a mission patch is, it depends on the crew. It often represents the mission itself, the objectives of the mission, but it also can include very personal elements that is personal to the crew members themselves. The 1 star that Anna Fisher had added to the patch to represent her child, because she was the first mother to fly into space. So it can be a combination of culture, personal, personal representation. It can represent the mission itself. It often includes elements to represent all of these things, and each, but the entire crew has to agree, and that's the teamwork that is necessary in order to have a successful mission. Is a crew that works together in collaboration, and one way to foster that collaboration is starting off with the mission patch. It's starting off with the design. So all the crew members have to agree to the design before they present it to NASA, in this case, for review and acceptance. I will say that one of the things I love about the designs of emblems and that become patches is that the A in STEAM, so the A stands for arts, and the A in STEAM makes STEM memorable because it's the artwork. You will often, the arts is very important when it comes to the exploration of space, and you often will hear astronauts tell the story that it's the artwork, it's the representation, and I love your patch. I love that. But it's the artwork that forms the representation of who you are as a crew and as a mission. Yeah, the Global Educator patch is beautiful.
That's the Limitless Global Educators mission patch. And we also have one that's really designed for the Nigerian 2024 Limitless Space Institute cohorts, you know, so every time I'm taking it with me, we also designed this with it. This crest, can you see it?
Oh, nice.
So we designed the crest with it.
Yeah.
That's on my cloth now. And then we have it. So this was designed. So just to buttress to our educators that these things that we are saying are things we are doing as educators and even inspiring our students to do same.
Yeah.
And they are doing it. They are participating in experiments. They are participating in missions. They are participating in challenges. So there is no stopping anyone. Thank you so much for that response. Then someone else asks here.
You're welcome. Thank you.
This person says, each mission patch, does it have a scientific or explorative focus?
I'm sorry, your audio broke up, so I couldn't hear you.
Okay. This person says, is the mission patch designed by the astronauts? Is the mission patch designed by the astronauts? That's the first one. Does it have scientific or explorative focus? That's the second one. Is it designed by an astronaut? That's the first one. Does it have exploratory or scientific focus?
It often does. Again, it depends on the crew. And that's what's lovely about the I think the mandate of every crew for every mission is to create an emblem that is representative of them, of the mission. And it's completely entirely up to the crew to decide what they want their mission patch to represent. It often, and so there's no policy or requirement that it has to have certain elements. Is entirely up to the crew to decide how they want their mission represented to everyone else. And that makes it very creativity that goes into deciding what you want in your patch I think is lovely. It's open to the possibilities. I think with students, one of the things that students can actually do is infuse their own personal identity, culture, color, shape, design elements. If their mission patch is to represent a mission, such as a school project or their school or their class, these are things that guide them and inform the group of students to include things that could represent to other people their school, their project, their team project. So it's a very much a team effort, which is what I like about how NASA facilitates the creation of emblems. It's completely up to the crew to make those decisions. Yeah. And what I provide on my site are some guidelines. So that worksheet for small group student activities to create crew patches takes some of the decision making early on. It kind of takes that. It uses chance to decide what the mission is and what some of the key elements will be. So it helps students focus around some very specific criteria and goals and roles. So it helps them quickly come together to function as a crew and collaborate on a design and the story of their mission.
Awesome. Awesome. Those are the key points that I believe the teachers are taking away. We want to foster 21st century learning skills with our students, in our students, teamwork, collaboration.
Yes.
Critical thinking, problem solving, and innovation. Thank you, Mr. Logan. That would
You're
be
welcome.
all for now. If you have any further questions, I will contact them and email you those questions. Thank you so much for taking time off your busy schedule to
Have
share
a great
with
day.
us. Bye.
Bye-bye.
So, distinguished colleagues, please say thank you to Mr. Logan for taking time off to share with us. I hope you have learned some important things to help you in your own classrooms. So it is on these notes we will be wrapping it up today. I will see you all. Can you hear me? I will see you all tomorrow by God's grace with the continuation of the training and day 2 of the training. We had some internet glitches, network glitches. We hope that the network resolves. Really, there's no one who can work on improving the network. Network just behaves and happens as it pleases. So, but so far, we thank God that we are able to achieve something. And I'll see you all by God's grace tomorrow, which is the final day for the 2-day training. We will make sure that you have access to the live stream recordings on the YouTube channel. So do yourself a favor to review the ones you missed for those who got locked out because of network issues. The whole thing is recorded and it's there on the YouTube channel. You can always reference it and watch again. So thank you so much for your commitment to your own personal growth and development. I'll see you all tomorrow by God's grace. Cheers. It's Oluwabanke Adewusi signing out. Bye.